morning, good afternoon, everyone. Welcome to January's TBC Trimble Business Center Power Hour. Today we'll be talking about working with point cloud in TBC. Go ahead, Stephen.
Hey, good morning. Hey, it's me, Stephen. I'm with Joe today, and it's my pleasure to be here to help Joe explaining that topic, working with point clouds in TBC.
Yeah, so Stephen's a part of our geospatial support team. He's based out of Raunheim, Germany. And Stephen, could you advance the slide?
Sure.
There we are. I'm Joe Buck. I'm the TBC product manager based in Westminster, Colorado. And there's my email and two of my favorite things, the Chicago Bears football team and my daughter Nora. Definitely not in that order, but happy to be here with you today. Thank you for attending. Just some ground rules or typical procedures here. The questions are open. If you do have a question, please type it in there, and I will kind of moderate and ask Stephen or bring it up if it fits in the workflow. There will also be some time at the end of the presentation that we'll be covering and answering your questions. So please feel free to submit anything that you would like. And if we don't get to you during this session, we do have them logged, and we'll follow back up with you. And so Stephen is already on. I want to thank Stephen again for really taking the lead on this. This is going to be a good show here. Also, thank you to Michael, our excellent Marcom support, for putting all these together. So with that, I will turn it over to Stephen.
Yeah, thanks, Joe. Maybe a few more sentences about myself. So I'm working since 2010 with Trimble, mainly in geospatial technical support. So my daily work is mainly with the dealers that we have, coming question about TBC, Wheelworks, and all other products that we have in our Trimble world. Yeah, thanks, Joe, for inviting, so I can hosting that topic. I'm presenting from Raunheim, Germany, and yeah, I will start to present you the agenda for today. So we would like, or I would like to introduce you about the point cloud, working with point clouds in TBC. Here are some key points that I want to address. Scale factors with survey and scan data. Then I give you a demonstration in TBC working with point clouds, giving you an overview about the import-export functions that we have. And the fourth point will be covered by Joe, point cloud data scenario in TBC, and then we have time for question and answers and some resources, and the next step, let's say, was coming in the next TBC Power Hour. Starting with scale factors with survey and scan data. Here are some few basic information. So when we talk about scale factors, we should keep in mind that we need to be distinguished between ground and grid coordinates. So what are the ground coordinates? So ground units are computed when you measure distances, for example, with tape. So the scale factor is equal to 1. If we're talking about grid, then it's normally known as grid protections from ground through a scale factor, not always equal to 1. As you can see on the right-hand side, a nice picture showing the differences, let's say. And the scale factor is applied differently in TBC and Wheelworks. That's important, and yeah, you should keep in mind this kind of sentence when you're working with point cloud data. It's important to recognize the distinguish between the grid and ground-based coordinate to understand how TBC handle different source of point data. I have prepared a few different point data sets coming from an aerial source and from a terrestrial source. And I want to show you later in the presentation how we can handle this in TBC.
Yeah, and it's important now that TBC and Trimble has introduced the support for the SX10 total station that also scans, is introducing a new set of tools for the surveyor who may not be familiar with traditional scanning approaches, may not have even heard of our scanning office software, Trimble RealWorks. That's what that TRW is there. And so here's been our challenge of trying to educate people and inform people on working with different scaled point clouds, and that's really the motivation for today's session.
Yeah, thanks, Joe. Grid-based or ground-based coordinates supported in TBC, so TBC can handle this. That means grid and ground coordinates can be handled by TBC. Depending on the project or requirement, surveyors need ground-based coordinate as well as local coordinates. So TBC use a combined scale factor to transfer coordinates between grid and ground. That's also important. And in my presentation or demonstration in TBC, I will show you where to find this combined scale factor in TBC. On the other side, on the Trimble RealWorks side, Trimble RealWorks supports ground-based coordinates. The reason for it is that the scanning guys who typically work in project or sites, they don't require a defined coordinate system with datum or geoid. Example for these are buildings, pipe systems, or other structures. Therefore, Trimble RealWorks does not support grid ground data scaling like TBC. So that's also quite important to know or to be aware of how TBC handle point clouds, and on the other side, how RealWorks is handling point clouds. So I want to start with the first demonstration from my side. Working in support, let's say we have seen cases that dealer want to know. Now they have some terrestrial scanning data, as you can see here in TBC. And when I'm switching to the 3D view, you can actually see there's a point cloud collected by a terrestrial source, where we have scanned the container or area of it. And the question was for one of our dealers that they compared actually the coordinates, maybe one of the corner over here in TBC and RealWorks, and their question was that the coordinates are different. The reason is that they imported the point cloud incorrectly in RealWorks. So if you want to see in both office softwares the same coordinates, you have to select the point cloud. I will do this in the next demonstration, but just quickly here to mention, selecting the point cloud, and when you go to export, we have certain export functionalities about the point clouds, and we also have the functions to export the point cloud into ground or grid coordinates. So if you want to get these point clouds exported to RealWorks and to have both point clouds located on the same location, you have to select grid in that case. I had done this for RealWorks. Just as an example, I will pick a point here in the point cloud, just to give you an understanding how this looks like. So for example, if I'm putting a point over here on this label, here on the right hand side, you can actually see the point cloud, the coordinate of the point. On the other screen on my PC, I have opened the same point cloud where it exported the point cloud to grid. So you see here actually the same scenario. And when I'm picking here also the same point, getting very close to it, you see actually the coordinates are the same. You see here the easting and the northing. So actually, this is the workflow if you want to have TBC and RealWorks aligned to each other. So keep in mind exporting point cloud from TBC to RealWorks using grid scaling. Good, I will jumping back to the presentation. So the next topic or the next demonstration would be having an aerial data set in TBC available, and on the other hand side, terrestrial data set, and bring these two different type of point clouds together into one project. So depending on multiple point clouds from different hardwares, it's important to understand what's the scaling of the point cloud, whether you want to bring it into TBC or RealWorks. So here the terrestrial point cloud system, such as Trimble TX8, TX6, the VX or the S series with vision technology, or even the Trimble SX10, are typically collected using ground coordinates. Aerial imaging point cloud systems such as Trimble UX5 or UX5 HP are typically collected in grid coordinates. So here you can see there are two different types of coordinates available. So working with point clouds in TBC, this would be the next topic. And here I will also directly jump into TBC and give you some more information, or let's say show you a few things in TBC. I will start with an aerial data set, as you can see here in the plane view, what we had collected from the aerial point of view. Here you can actually see the data set. So once we start with point clouds, we can go to the point cloud tab. We have different options available. For instances, the classification region. Here we can have options available like buildings, ground, high vegetation, poles, and signs. So in that case, it makes sense to extract the ground. So there's a specific option available in TBC called extract grounds. If you did that, so I had done this up front because it took a while, around a few minutes. So I extracted this ground region over here. When I'm selecting the default, you can actually see that it's just the ground. When I'm switching on the default, you can actually see. So here's the container that I was showing in the previous project. I will jump back in this other project in a few minutes. So you can actually see here the top of the container. So if you're hitting classify extract grounds, you only get the ground points extracted automatically from TBC, which is quite handy if you want to sample your data. Another step what we have is, for example, sample regions. So in that case, if we want to sample these kind of point cloud a little bit more, for example, if you say every half a meter, we can just go there, select a point cloud in the project explorer, for example, ground, and then hit store, and then RealWorks will only store every half a meter a point. So this will actually sample the point cloud. So in the beginning, we had 16 million of points. So it would be, after this sampling process, it would be less than that. So when we checking the properties for that region that has been extracted, and now we see we only have 1 million left.
Yeah, so one of the great benefits of working with point clouds is the flexibility, and however that can quickly and very easily lead to kind of data overload where you've got 16 million points. Well, depending on what your application is and what you're trying to get to a final deliverable, that could be just completely unnecessary. So the sampling tool here allows you to get the data down into a more manageable size, a more workable size based on what you're doing.
Yep, that's correct. You can even create your own region if you want, but I will handle this in another project. What else you can do with this data set, what we have seen here right now, you can actually extract or generate a surface over here by generate a surface. I have done this again by using the 60 million points. If we show the surface over here and disable the point cloud, you can actually see how it looks like. Then as a next step, if you have a surface for that project, would be generating some contours. For example, this would be my next step, would be another deliverable what we can extract from point clouds. So quite easy and handy. So here you can see create contours. So in the end, you can see the maximum and the minimum elevation from that point cloud. Just to give you understanding what makes sense of contour intervals. So I'm using 1. You can specify the specific layer if you want. I will leave it like it is. I will select smooth contours, that the contours looks more nice and pretty. And the label distance between the labels, I will select 30 meters and hit OK. So after TBC is processing now the contours, you will see actually the contour lines in our TBC project. If I'm disabling a surface, you probably see a bit more. You see here this index contour with the number, so 121 is the elevation for that contour, and you can use these kind of data set to export to whatever you need, for example, AutoCAD as an instance. But you can also draw drafting and you can plot this kind of contours. Good. When we are talking about export, that would be my next point on the list. So for that, I will enable the point cloud again. I will use the sample data, just 1 million point. So in that case, I will disable that one. So we have this point clouds enabled here. Then in that case, we are going to export. Here we have the point cloud exporter available and different types of exports, for example, E57, LRS, LRZ, POD, PDS, and so on. So there's a bundle of exports available. As you can also see here, there's a direct export to Trimble Reworks, as you can see here in brackets, called TDX. So, but I want to export my point cloud. I will selecting this one to LRS, and I will use ground scale. In that case, I will select a folder where I want to save my data, call it ground. If you want, we can still sample it, but we had done the sampling already. So that's why I'm selecting no, but here you can also do some certain samplings. Here, if you selecting yes, it's actually using the random type of random. So we have spatial and random. By random, if you're using random, you can actually type in the number of points that you want to keep. So here in that case, if I'm selecting yes, it would be 1 billion points. But my sample data is already sampled up to 1 million points, so that's fine. Hitting export. And this will be exporting a LS file. When we take a look about the data, we will find it over here. And it's listed over here. So 25 megabytes, so it's not that huge. That's fine. So yeah, these are the options in TBC.
We've gotten two of the same questions regarding the distance-based sampling. The sampling is just a simple grid. You know, think of a grid at that half-meter interval, for example, and TBC will pick the nearest point to that that grid spacing and extract that. So that question's come in twice.
Okay.
Also, here, while you're in the export, you see that RCP exporter option. That is to recap the point cloud software products from Autodesk. That export is unique in the sense that you have to have recap installed locally on the machine running TBC, as well as a valid subscription or demo license for recap for that export to work.
Yep, thanks, Joe. So I'm going forward to the next project I want to present. This would be terrestrial dataset. So here we have, close that one. So we have here the same, let's say, from the same area, dataset collected by a terrestrial data source, as you can see here. Here I want to show you what else we can do with the point cloud, starting with the limit box. Closing this one over here. Limit box can be found under the point clouds tab as well. So when I'm clicking on that, it's actually open up this limit box. You can extend on your certain needs. You can rotate in horizontal or vertical, as I can show you here. In this direction, you can also move it if you want a certain position. And the good thing, you can actually save these limit box by hitting this button on the right hand side. So when I'm clicking create, it will actually create a limit box called, in that case, it's limit box. But when I'm switching this one off and now turning on my limit box, it actually only shows that point cloud inside the limit box core. It's quite handy if you have different scenarios in your point cloud that you want to enable quickly, so not to lose too much time to segment the point cloud. So this is a quite good tool to handle point clouds. I have here another total station observations available. I will switch it off. It might be overload the whole scenario over here. I will close that one and going back to to the imagery that we have on the right hand side here. We have the autophoto option, so it actually creates autophoto based on the point cloud. When we're taking a look about this one, so it's actually show up this option over here, and when we zoom in, and for example, if we want to have an image on the side of the container, we actually need to define the plane definition. So there was already a plane definition defined. So we can go to new, for instance. This will open up a new window, as you can see here. So we can pick 3 points. For example, on that wall, 3 points, so that the plan definition goes really directly on that wall for the container. So I'm closing that one. And now when I'm zoom in to the point cloud, you can actually now define the corner of the image. So for example, if I want to have from that area to here, that image, we can also define the pixel size if we want. 1 centimeter should be enough. If we're hitting store, it will actually generate an image under our TBC project. So when we open this one, I can show you this one. So it's actually over here, that's our autophoto that we had generated here. So we will get a PNG file, a TIFF file, and a text file. This text file contains the link to the TIFF file and the four corners of the image with the coordinates in TBC, as you can see here.
Yeah, so we added that text file to allow you the flexibility to take this product and move it into another drafting package. We understand that TBC may be just a portion of your workflow and your office software, but this those coordinates will allow you to position these resulting orthos into another package using whatever coordinate system you're in. Anything created in TBC right now will automatically be positioned in its real world coordinates and the coordinate system that you are working in.
Yep, which is quite good. One more point to that create autophoto feature in TBC. When you take a look about the view filter manager, you will get the extra entry called georeference images. So these images, these TIFF files are actually georeferenced. That's why this text file comes with that image. Good. What else we can do with point clouds? So auto rectified image. So here we actually using the information about the images that we had collected in the field. So when we click on that, it will open the station view for us. And in that case, I will open the station S3. So here you can see the same scenario just from a image point of view, from a station point of view, where we had collected the images. The menu looks quite similar to the autophoto creation, but here you can also define the a plane definition, let's say. So I'm clicking on that and open up this window again. So here I'm selecting also 3 points. So clicking over here, clicking over here. Oh. And maybe I'm selecting somehow it's not working. Let's try again. Picking 3 points. It does not recognize. Maybe I'll start again. I'm still. That's why I'm get confused. So we have to select also the right stationing on the top. So here in the station view, we are in the station S3, but we also need to select this in this view because then TBC is actually using this view direction. So in that case, start again the plane definition, picking 3 points. Okay. And then picking the corner of this. For instance, this was not correct. We'll try again to create a totally new one. 3 points. Not sure why it's not.
You maybe try picking from a 3D view or plan view, Stephen?
Yeah, I will try this one. Yeah, thanks for the hint. So now I'm this 3D view, so I'm trying to pick from here. Yeah, that works. Okay, so we have defined the plane definition now, and I'm closing this one. So from here we can select the corner of this image. So for example, this one, and then you can actually see this is our frame of the image. Pixel size, I will leave it 5 millimeters and say okay. In that case, when we are going back to our TBC project folder, we can see there's a PNG file generated, and here it's actually using the image information, not the point cloud information, for generating this PNG file. Here we also have a TXT file available. When we open up this one, you can see here also the coordinates of the image, the corners, top right, top left, and so on. Good. What else we can do with point clouds? I will switch these images off and want to go to the cutting plane view. By using cutting plane view, we can use the point cloud, for example, to generate CAD deliverables, for instance. So when we go back to this plane view session, selecting elevation, that's fine. Now when we zoom in, we have now this point cloud cut it in a certain elevation. So here in the plane view, you can actually see it. And here we're actually looking from the top view. And another point to extract deliverables from a point cloud would be using the CAD features in TBC. Here in that case, I'm using the line string feature. So when I'm opening up the line string, I can give it a name, for example, line. I'm selecting auto close. Maybe a hint from my side, when you go to the snap options here, click on that. So we have this auto snap feature available, and when you're clicking auto tracking, it actually gives you indication if the object or if the lines that you are clicking are perpendicular to each other. So I can show you that by pressing OK. Line string will open. Hopefully. It's not. It's not opening. That's bad. Probably I need to restart TBC. I'm sorry for that.
So while Steven's working through this, it's never a good software demo unless there's...
No, I'm very sorry about it.
Catastrophe, right? No problem. Hey, so while Steven's working through that, I wanted just to kind of wrap up how the cutting plane and the plane definition manager kind of fit together. So the plane definition manager is where you'd actually create the plane. And what the plane is you're just kind of shifting that world coordinate system, that 0, 0 plan view plane that's in, basically the XY plane to a custom orientation. And based on that custom orientation, in the cutting plane view, so the cutting plane is just a view of the plane definition, you can then create your deliverables, like Steven showed, creating the ortho photo or creating the ortho rectified image, or now if TBC will behave for us, drafting on that plane. So just think of it as moving your kind of traditional plan view into a custom defined plane that you've defined to draft on.
Yep. Thanks, Joe. So TBC, it's up and running again on my side. As the next point, I want to talk about how we can bring our aerial data set into TBC. This would be one of our next point to discuss. So in the beginning, I exported our aerial data set to ground. As you can see here, that's our LIS file. So when we drag and drop this file into TBC, you will actually see this kind of warning, which says that the project includes a mix of station-based scan data, for example, total station or scan stations, and you need to be aware that it might be that the point clouds that you want that is showing in TBC are might be different, or you need to be aware about this ground distance topic, which need to be scaled by a combined scale factor. So when I'm hitting OK, so our point cloud from the first project will be imported into TBC. And if you have this, I haven't selected. So here I have just exported the ground, but I haven't exported the top of the container. I will just do this. So when I'm going back to this other project, so when I'm selecting both point clouds, I'm selecting this one again. I think one ground. Why I want to do this? Because then you can actually see that there will be point clouds on the top of the container. As you can see here, when I'm importing that file 01, same error message or warning message, is not the error message. And now you can see that the point clouds fits to that other point cloud, as you can see here. So might be the coming questions where we can see the combined scale factor. So when you go to the project settings, on the View tab, you go into the point spreadsheets, and here you scroll down until you see here the combined scale factor. As default, it's hidden. I'd showed it up for that example. So when we open up the point spreadsheet located under the View tab, you can actually view it. And here on the right-hand side, hopefully you can see it, you can see here actually the combined scale factor listed in TBC.
So where Stephen went there, it was in project settings. Could you just reopen that one more time, Stephen?
Sure.
So that's the little gear icon in the upper left, and then in the view header along the left, and then point spreadsheet, and scroll all the way down. We don't make it easy on you, but that data is critical, especially if you're looking to troubleshoot different source data, why some point cloud may not be coming in and matching up with another point cloud. And this is what Stephen's showing in the spreadsheet. Thank you.
You're welcome. So when I'm jumping back to the presentation, there I want to talk about the import-export functions that we have in TBC for point cloud data. Here we have on the import side, we have the E57, LIS, PTX, PTS, XYZ, and POD. And TBC treats the coordinates from Trimble SX10, S series, or VX total station. It's called as conventional survey data or terrestrial data set as ground scale, that the data to grid using the project combined scale factor, as I have shown you. If your import coordinates are already scaled to grid with their own scale factor, TBC does not read this scale factor, and an additional scale factor will be applied to the point cloud. So please keep this in mind. Importing point clouds from common point cloud data formats into TBC without conventional survey. TBC imports this data set as grid scaled, and TBC does not apply the project combined scale factor if applied. So that means if we exporting, for example, our aerial data set to grid, that means grid LIS, and this other terrestrial data set also to LIS grid, and importing both gridded LIS files into a new TBC project, both point clouds will be aligned as I have shown you in this terrestrial data set. So this one you also need to keep in mind.
Yeah, and that's why Stephen did what he did when he exported the aerial data out as ground. TBC will read that file natively as ground and knows, oh, okay, in the project I had the terrestrial data, there's a scale factor applied, then TBC will automatically scale the ground scaled point cloud, and the data will match up as he showed.
That's right. On the export side, there are different settings available. So here with this nice table, it's actually give us a good overview what kind of export file format have which options available. For example, E57 have the ground and grid option available. We can't sample it, but the units coming into meters, and as you can see here, the other file formats are slightly different. But this should give you a nice overview and makes the life easier if you want to export point cloud data from TBC. Good. The next topic would be point cloud data scenarios in TBC, and I will handle over to Joe.
Yeah. So thank you for those demos, Stephen. And we threw a lot of information at you, and a lot of really good information. And for surveyors out there who may not be in tune with the scanning market or experience with scanning, this is new, and this can be quite confusing. You really have to be paying attention with what you're doing with your point cloud data. And so based on that, we were motivated to do this session, and then also create a product bulletin that will be posted. It's available now. Your Trimble distribution partners should have it for you if you go and inquire about it. But it will also be posted with the recording and the presentation. It's a 7-page document that a lot of the text will look familiar if you've been paying attention here. A lot of what we've been talking about will be covered and documented. So for your reference, to actually understand what's all going on, we can only cram so much into these 30, 40 minutes of demo. And one of the nice things of this bulletin is I think it's 6 scenarios that we talk about, and with a tendency towards assuming Trimble-based hardware was used to collect it, but just in general point cloud behaviors. So that little screenshot there shown as a terrestrial survey point cloud, from example a Trimble SX10 S series or VX instrument into a grid-based TBC project, and the kind of bubble diagrams there will show you actually on a scenario case-by-case basis what is going on in TBC. All right, so now we've got some time for some questions. I do have a little bit more presentation. However, I've got some questions here that I haven't been able to get to. So John asks, if portions of the objects or point clouds are classified incorrectly, is there an easy way to change or merge the incorrect objects to the correct classification layer? So the answer there, I don't believe we showed it, but Stephen talked about the point cloud classification, where there's those 5 kind of pre-built categories. Those routines are iterative, so to a point of diminishing returns. If you, for example, had some high vegetation data that was not getting picked up, if you ran that routine again, thanks for pulling that up, Stephen,
Yep.
based on the region that was classified correctly or you wanted to clean up, it should go through and prove it. I've found, going through that on a region by region basis, 2 or 3 times if necessary will improve your results. What you can also do as well before classifying is leveraging that limit box tool that Stephen showed, and using those keep in, keep out tools, which are viewing tools that will allow you to basically hide and make unselectable any point cloud noise or any areas that you don't want included in a specific point cloud region. So lots of flexibility there in the point clouds tab. David asked, can you colorize the point cloud based on an ortho photo in TBC? The colorize tool in TBC is for SX10 based data. Right now you cannot colorize point clouds based on ortho photos. What you can do, and a nice little trick for topographic maps, is if you have a nice big ortho, say for example an aerial UAV hardware, you can set the ortho image as a surface member if you've generated a original ground or an as-built surface, and that will actually drape the image onto the surface. I've been running these TBC tips of the week, and this has come up now 3 times this week. I think I've got my topic to generate a tip of the week. I'll show you how to do that in my little tip of the week here. Just going through some extra questions.
Joe, I can also maybe give a hint to the users. So in case if you're working with this auto-rectified image, where we actually using the image information, you can probably improve the image quality when you're using the process panorama features, where we actually using these 2 options. So that might be a good hint for those of you who want to work with the auto-rectified image.
Yeah, so you'll notice there's 3 options. Process panoramas isn't necessarily new, but that's also a very viable option. Nice to view this then in context. You can see there's some Google Earth options there as well down at the bottom to view your pano directly into Google Earth. A couple more questions. Can you export specific points in a limit box only? So the ability there with the limit box is you'd be able to select a series of points, a collection of points, and create a region from that. And then you can export that specific region if needed.
Yeah, that's right.
Some customization questions. Right now, we've got those 5 pre-built classification types: the high vegetation, structures, poles and signs, power lines, and ground. We're constantly looking to grow. We are in an aggressive growth mode here with supporting the SX10 and scanning, generic scanning workflows in general here on TBC. So right now, there is not the ability to for the user to customize specific classes to extract. Another tool that is worth mentioning is the semi-automatic smart pick extraction tools. And Stephen, if you wouldn't mind, you don't have to get into it too much, but can you go into the CAD tab?
Sure.
And click on line string. And just click through it. You don't necessarily always have to name your line string. So click OK.
Yep.
And then you'll notice on the right of the coordinate box, there's a little cloud icon with a little target. If you click on that, Stephen.
Yes, it will open up this window.
That will bring up our point cloud smart picking, which is, again, a semi-automatic approach that we're expanding to different objects. Right now, we've added face of curb and gutter extraction. So how this works is if you select one of those and you find a curb and gutter that you wish to extract, you pick on the gutter line, for example, in plan view or 3D view, you'll get a little cross-section slice of the point cloud with a little red plus sign that shows where you picked. And in this cross-section view, you'd be able to correct your pick so you're confident in knowing that what you're extracting is in fact that gutter line. We are investigating and implementing more both line kind of based objects, string based objects like curbs and gutters, roadway markings, for example, trees, signs, poles, things like that. We're all investigating and hopefully have out to you in a release build here pretty soon. All right, there's probably a half a dozen more questions that I'm sorry I won't be able to get to, but I do have them, and we'll be reaching out to you shortly with those answers. If you return back to the presentation, I can just get to some resources and next steps. All right, so we do have a new web page. Trimble.com/TBC would be an easy way to get to it. We wanted to focus on more graphics and visuals, more interactivity. We've posted the some new customer testimonial videos, surveyors in the field using TBC and getting their honest, positive opinions on using TBC. Go ahead. We've got a very successful YouTube channel, the TBC survey channel, about 200 videos up. And this is really nice. For example, the Smart Pick features are newish to TBC. And when they were released, I think two versions ago, we created a quick little video of how those work. So these videos come out around each new release that highlight a lot of the new features, just a couple of minutes apiece. We want to respect your time, make this learning as easy and as accessible as possible. So I'd encourage you, if you've got any questions, especially with the scanning and the things that we kind of talked about or touched on today, a lot of that is new, within the last year or two. So there'll be these short little intro videos on our YouTube channel. Go ahead. And then our ever-increasing library of TBC Power Hours. We've been doing these since, I believe, 2015, each month, every last Wednesday of every month. Those recordings are available. We've been also adding the data sets and the presentations. This presentation will be available. The data is a little large to be posted, but I will also post that PDF of the product bulletin to get you a nice reference for what we talked about here today. Go ahead. Our TBC community page has been growing with more and more content and questions. It's a great way to connect with other TBC users as well as the development team and the marketing team. We do check this page as well, and very searchable, very accessible source of data and questions. Go ahead. The next steps here, if you're interested in what you saw, if you're not a TBC user, I encourage you to download TBC. It's a free download, and then you're also able to get a free 30-day demo license from your local Trimble distribution partner. Our geospatial marketing team has created a new locator map, much more interactive, and be able to select your local Trimble distribution partner if you do not know who they are from this site. Go ahead. And then teasing the next Power Hour, we're going to bring our old friend Boris back for a session on BIM for land surveyors. He'll be talking about some of the supported structural objects, some of the COGO tools, integration with some Trimble Access apps. There may be another special guest we're looking to line up for that as well. So stay tuned for that. Registration should be coming out here in a week or so. That will be on Wednesday, February 28th. And we will likely get back to our 2 sessions of U.S. Mountain Time morning and a Mountain Time afternoon session as well. All right. So with that, Stephen, do you have? We got a couple extra minutes here. Do you have that cutting plane back up and running where you're trying to do some drafting and extraction? There's been some questions on wanting to see that workflow completed.
Unfortunately not, no. Still struggling on my PC. Might be a PC problem on my side.
Okay. All right, let me scan here real quick. John asked, do we need to worry about scale factors when exporting to Trimble RealWorks?
Yeah, as I tried to explain in the beginning, if you want to export your point cloud from TBC to RealWorks, you need to keep in mind that Trimble RealWorks can only handle ground coordinates. So in that case, from the TBC side, we have to export these kind of ground information to RealWorks to handle that. Grid. Because once we're exporting from TBC side to Grid, we implemented already the scaling, so then TBC Trimble RealWorks can handle that information.
Okay. Hector's asked, how can I find the combined scale factor value in TBC that is applying to the point cloud data? Is there an area averaged for a combined scale factor? Is there a single project combined scale factor adopted?
For the aerial, so if you have point clouds included, so when we go here back to our point spreadsheet where we have this combined scale factor, this actually is for each point, but not specific to a point cloud. It's as you can see here, specific to the points which are available in TBC.
Okay. Would you mind going into the survey tab, Stephen?
Sure.
And going into local site settings?
Yes.
So this is the local site settings setup where you have a project location, and typically the ground scale factor is computed at that location. As you can see, that is Stephen's using ground, so he's brought the scale factor, so grid equals ground in this case, and the scale factor is applied at that project location, which you typically want to be a centrally located point in your project, and you could see what that is there. You could also manually key that in, and that's what would be used upon export.
Right.
Well, it's the top of the hour. Thank you for attending, everyone. If you've got any last-minute questions, please get those in. Again, I want to thank Stephen for his time and expertise with this, and we look forward to seeing you next month talking about BIM for land surveyors using TBC. Thank you, everyone.
Thanks, Joe. Thanks, everyone.